Okay, let's start our discussion. I'll be sharing the screen. I think everyone did the first question. Once I'll explain it. During a scoring heat wave, the temperature in a chef land reached a record high of X degrees. The next day, recorded temperature was Y degrees. Find whether this was a new record high or not. Simply, we need to take input as like X and Y. If X is first, we'll observe the test cases once. If temperature of the second day is higher than the first day, then we need to print the output as S, otherwise it is no. That's it. If X is greater than or equals to Y, we'll print it as no, else S. This is clear for everyone, right? Is there any doubt in it? Is this clear for everyone? Okay, let's move to second question. Yeah. Second question. Chef and Chefina are out on a long road trip. The average speed of the car after 10 hours of driving is X kilometers per hour. Chef wants to achieve an average speed of Y kilometers per hour given that he can travel a maximum of 100 kilometers in 1 hour. We need to find the minimum number of additional integer hours required for him to reach the target average speed. So here we are given with two values x and y, where x is the average speed after 10 hours and y is the target we need to achieve. These are the two inputs. So this is simple mathematics. To achieve the y speed, we need to find the minimum amount of time. That's it. Here, suppose let's check the test case 1, 50 and 51, where x is 50 and y is 51. So 50 kmph per hour, 50 kilometers. So in 10 hours, we can travel 50 into 10, which means 500 kilometers. Now we need to find the time to reach the average speed 51 kmph. So simply distance by time. But here we don't know that we are we are having two variables, means 61. This is one variable and we don't know the time also. So here we are having two variables which we don't know. Suppose let's check the second test case 60 and 80. 60 kmph in 10 hours, 600 kilometers, and then we need to reach our target as 80. Here we don't know the value 100 and 10, but in question they are mentioned like 100 kilometers in 1 hour is the maximum speed. So simply here we'll apply the simple mathematics here. According to once check the this test case, 500 plus 61 by 10 plus 1. So I made this formula 10x plus 100 into 100 is the maximum value given in the question, and we need to find the time into t by 10, which means 10 hours. They have given in the question the average speed of the car after 10 hours. So the 10 plus time we need to find, which is greater than or equals to y, because here the maximum speed is 100. I mean, maximum distance 100 kilometers in 1 hour. So, this is greater than or equals to y. Simply, we'll do this and we'll get the 10x minus 10y by y minus 100. We are given with x and y, so simply we can find this. As they mentioned, we need integers. We'll put it as ceil. That's it. Ceil of 10 into y minus x by 100 minus y. So is this clear for everyone? Okay. Remaining Prithvi sir, Prithvi circle, is this clear? Sneha. Okay. Just we need to apply the simple mass. That's it. Okay. Let's move on to the third question. In third question, distinct substring. A binary string is a string consisting of 0 and by. Yeah, we define an island as a substring consisting of all zeros bounded by ones. For example, in the string 1 0 0 0 1 0 0 0 0, there are two islands 0 0 0 bounded by ones and 0 0 0 four zeros bounded by one and end of the string. Here, what is the meaning of island? Island means the zeros should be bounded by ones, or else it should be bounded by one at one end and another end it should be like end of the string. This is the meaning of island. First we need to understand this. Then here we are given with integers n and k. N is the uh, length where there exists a binary string of length of the binary string, and k is the number of islands. Just we need to give the output as yes or no if k number of islands is possible in the string of length n. That's it. We need to do. We need to understand one thing here. Suppose let's take these test cases. Yeah, here, first let's take 6 and 3, where n is equals to 6 and k equals to 3. Here, one thing we need to remember is the island should be the like length of that island should be distinct. So, here our k value is 3 and n value is 6. We need to check whether this three islands is possible in length of string size 6. So simply 0, 1, 0, 0, 1, zeros, 3 zeros. Here this 0 is surrounded by 1 and then boundary of the string. And then these two zeros are bounded by two ones. So this is one island. This is one island and these three zeros are bounded by 1 and then end of the string. So this is the minimum possible string with to satisfy this three to possible three islands. So minimum length of the string is 1 2 3 4 5 6 7 8. So minimum length should be 8, but here we are given with 6, so definitely it is no. Let's check one more test case. 7 and 2. 7 n value is 7 and then k value is 2. So for this 0 1 0 0, this is the minimum possibility. So here the minimum length should be 4, but here we are given with 7. So simply we'll keep remaining values is zeros. That's it. So what we need to check here is, here first we need to calculate the k into k plus 1 by 2. Simply that's what we did, right? Here means number of zeros. Here one zero with which is considered as one island. Next two zeros. Next three zeros. These are the 1 plus 2 plus 3, 5, 6. So this is the minimum length. Simply we'll calculate the sum and then we'll subtract the sum plus k minus 1. Why I did k minus 1 means here I need two ones here. K minus 1, 3 minus 1, 2. So this is the minimum possible length of the string. So if this condition is satisfied, we'll print s. Otherwise, it is no. That's it. There is nothing else. Is this clear for everyone? Yeah, yeah. All right. Yeah, okay. The remaining questions will continue by Sudarshan.
Hello. Hello. Am I audible? Hello. Hello. Okay. So let me just present Satvika. Hello. Hello, Satvika.
Yeah, yeah.
Stop sharing. Okay. So now let me just present. Hello. So is my screen visible? Some of you please say something in the chat so I would know. Okay. So let's discuss the fourth problem. So chef has given you an even integer n. Find whether there exists three distinct integer a, b, and c such that a, b, c are primes, okay, primes, and a square plus b square plus c square is equal to n. So the question is pretty simple. I mean, at least the language is simple. So everybody understood the problem, right? What the problem is saying. Hello, hello. Did you understand the problem? Okay, yeah, we'll discuss about it. But just tell me, okay. So I think the problem is pretty clear. So I guess this is the fifth problem, right? So first we need to discuss the fourth one. So let's see the fourth problem first. We'll discuss the fifth one later. So you are given an odd integer n. Generate an array A of n positive integers such that A of I is lying between 1 and 10 raised to 5 inclusive, and bitwise AND of each prefix array is greater than equal to bitwise XOR of corresponding prefix array. Similarly, bitwise AND of each suffix array is less than or equal to bitwise XOR of corresponding suffix array. You can prove that at least one solution exists. So this is the problem number 4. Okay, let me just explain the problem. What is the problem saying? So suppose you are given an array odd integers, right? I mean, odd number of integers. Suppose this is 5. So what it's saying is that these are the elements. Suppose the screen is visible, right? Hello. Yes. Okay. So these are the array elements. And what is it saying? That if you move from this side, then okay. First of all, I am representing bitwise XOR with this plus sign. As you know, this is the symbol of XOR, and bitwise AND by this symbol. Okay. So what is it saying? That for every subarray, this, 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 and this. Your bit for, as we move for the prefix. Okay, these are prefixes. as you move from the beginning of the array. For every prefix, your bitwise and should be greater than equal to bitwise or. So far, good. Hello. Is the whiteboard not visible? Hello. Is it visible now? Okay, wait. Hello. Is it visible?
Yeah, your screen is visible.
Okay. So I guess I have to explain it again. So suppose what I was saying is, suppose you have an array of odd number of elements. Okay. Screen is visible, right? Hello.
Yeah, it is.
Okay. So suppose these are the elements. So what is it saying that, okay, suppose these are the elements. If you move, this is the prefix side and this is the suffix side. Okay. If we these are called prefixes of the array. If you move from the beginning and from the end, these are called suffixes. These are just definitions. I just wanted to make it clear. So suppose you have an array of odd number of elements, and what is it saying that the bitwise or yes, it was opposite. So for the prefixes, bitwise and is greater than or equal to bitwise or. Hello.
Yes.
Okay, so the screen is visible, right? So the bitwise and is greater than equal to bitwise or, and if you move from this side, your bitwise or is greater than equal to bitwise and. So if we look at the example in example 1c, for n equals to 3, they have made an array of 5, 6, and 3. Why? Because for the prefixes, if you take 5, single element, see, one thing is clear, right? That for single element, the bitwise or and bitwise and both will be equal. So therefore, this equality will be satisfied, right? Hello.
Yes.
Okay, so for single element, it is clear. Now, for more elements, see, they have written one particular combination for 3 elements. But you guys see, you can observe one thing. Uh, Let me write things, okay? Suppose A is a number, then A is or A and A and A. So what is the value of these two things? What is
First
A is
one is 0, second one is A.
okay, cool. So that's right. A is or A is 0 and A is A. So let's observe one thing, okay? We'll do this problem piece by piece. So suppose these are the elements, odd number of elements. So let's take 5 elements. So if I take a number A, I keep taking A only. Suppose I fill all the elements or entire array with A only, okay? So then for every element you see, for first element it is satisfied as we have discussed. For these two, now A is or A, which is your 0. And A will be always equal to A. Therefore, A would be greater than equal to 0, right? If you take a positive value of A, then A will always be greater than equal to 0. Therefore, our inequality, which is A and A, because for all elements, if we keep on taking and, it will remain same, but XOR will keep on changing, right? This will be 0 when you take XOR. When you take XOR of these three, this will be again A. So XOR will oscillate between 0 and A, but AND will always be A. So AND will always be greater than or equal to XOR, right? This is clear?
Yes.
So, okay, so we observe that if we take all the elements same, then our prefix condition will be satisfied, right? So suppose I've taken A 5 times. So my prefix condition is satisfied. But what about suffix? If we move from backside, now A and A from backside, again, as all the elements are same, the same inequality will be from both sides. So again, and will be greater than XOR. But we don't want this, right? If you look at the problem statement, it's saying that for the prefix, bitwise and should be greater, but for the suffix, bitwise or should be greater, right? So one thing is clear, all elements cannot be same. So what you can observe is that suppose for some elements, I take some elements, suppose the total length of the array is n, okay? For some elements, n minus x elements, the bitwise XOR is suppose A. Okay, I take the n minus x elements. I'll discuss what is the value of this x. Suppose n minus x elements are A, okay? And let's look at the last elements. I don't know what are, these are x elements, okay? X. We'll find out what is the value of x. So suppose for these n minus x elements, the XOR is A, okay? If suppose for these n minus x elements, XOR is A and all elements are A, then can you observe one thing? Can you say something about n minus x? Hello? If the XOR of first n minus x elements is A and all elements is equal to A, then can you comment
X
on
is
n minus
even.
x? What?
N minus x will be odd and n is odd, so x will be even.
Okay, that's awesome. Okay, that's a great observation. I think the entire problem is solved on that observation only. Okay, so see, if x was even, n minus x is definitely odd, and the odd, if odd a are taken, then their bitwise XOR would be A, right? So somehow, see, suppose if I'm moving from this side, what is the problem I'm facing? The only problem is that if I take all elements same, then their AND will be greater than XOR. But I need to, from this side, I need to make XOR greater, right? So how, if somehow I make this AND, whatever AND is there, whatever elements are here, if I make their AND of these X elements, don't mind my handwriting. Okay, I'm not able to write with this mouse. So AND of X elements, if I make this 0, okay, these X elements have AND equal to 0, then what will happen that once the AND here become equal to 0, after that, whatever, you know this property, right? A or 0 and A and 0. Can you tell me what are these two values? What is A or 0?
A.
Okay, yes. A or 0 is A and A and 0?
0.
0. Awesome. So see, if I make the AND of these X elements 0, then after that, the AND will definitely always be 0, right? 0 and 0, 0 and 0, 0 and 0. It will keep on going 0, okay? It's clear? Hello, is it clear?
I got a little confused.
Okay, so what is the confusion? You can ask.
Uh, the last sentence.
Okay, see, what I'm saying is, see, first thing you observe that if I take odd number of elements here, the XOR will be A, okay? And since the
Yes.
entire number is even, so there will be some even number of elements left here, okay? What I'm saying is if I take all elements equal, then basics condition will be satisfied. But I was from this side, when I move from back side, I need to make sure that my XOR is greater, right? So somehow I have to make and smaller. And I know one trick that if somehow I make the and whatever elements are there, suppose there are x is even, right? So suppose x is 2. If x is 2 and there are two elements whose and here, and of these two elements is 0. So when I move from this side, for the first, if we discussed in the first, right? If from this side, the first element, suppose these two elements are in the last two, okay? For first element, what and XOR both are equal. So this inequality will be satisfied, right? Hello? Hello.
Yes. Was the first
So
element?
yes, for the last element, I mean first element from the last, if you move from this side, this element for this element, XOR and both are equal, right? Because it's a single element.
Yes.
So for this, it is satisfied. Now, when we take these two elements together, if somehow I make their AND equal to 0, then after that, if their AND is 0, hello,
Yes.
if their AND is 0, then when we keep moving this side, the AND will always be 0, right? Once AND is equal to 0, the AND will always be equal to 0, okay?
Yes.
Yes. So if whatever be the value of XOR will always be greater than or equal to AND, right? Because AND is 0. Whatever be the value of XOR, it will be greater than 0, right?
Yes.
Okay. So now we'll discuss the actual solution. So see, uh, these are your odd number of elements. Suppose there are 5 elements. What I'll do is for the first 3 elements, because I discussed that x needs to be even, right? For these, the first 3 elements, I'll take some value, 3a's. And for these 2 elements, I'll take such a value that their AND is 0. Okay, their AND is 0. And also, once I make the AND 0, this suffix will be satisfied because now XOR will be greater than AND from this side. But also, this condition also needs to be maintained. From this side, your AND should be greater, right? So till here, AND is greater. Till here, AND is greater in this one. Until here, XOR is greater in this one, right? Now, what will I do? I have made and equal to 0 here. So after this condition is actually satisfied. Now I have also need to keep this condition also satisfied. Till here it is satisfied. Now here and is greater than equal to 0. And here the and is 0. If somehow I make XOR of these elements equal to A. Hello.
Yes.
Okay. So till see 2 points are clear, right? Till here this condition is satisfied in this. And till here this condition is satisfied in this, right?
Yes.
Okay. Now, if I take two elements in such a way that their AND is 0, then this entire condition will be satisfied. And if their XOR is 0, this will also keep on satisfying. Why? Because if their XOR is A, if there is, for these two elements, XOR is equal to A and their AND is equal to 0, then what will happen? These are odd number of elements. So till here, XOR will be A. When you A XOR A, again it will become 0. So this condition will be satisfied because A and 0, because their AND is 0. So A and 0. Now for this entire list, as I move this side, A and 0 and will be equal to 0 and their XOR will be equal to 0. I have chosen in such a way. So again, these two will be equal. So this condition will keep on satisfying, and also we have made this condition satisfiable. So what we have to do is that for the first n minus 2 elements, so we'll make first n minus 2 elements equal to A. And now there's one tricky part. You need to choose two elements in such a way that their XOR is equal to A and their AND is 0. So, okay, you will I mean, for this part, you need some observation. Suppose if I take 1 and 2 as two numbers, now you can see 1 and 2 is your 0 because you can see by the binary and this is your 1, this is your 2. If we take bitwise and it will be 0. And their bitwise XOR will be equal to, what will be the bitwise XOR of 1 and 2? Hello?
3.
Yes. So bitwise XOR of 1 and 2 will be 3. So if I take A equals to 3, suppose if I take A equals to 3 for the first three elements, and for the last two elements, I take 2 and 1. Now, can you check the condition is satisfied or not? See, if we move this side, for every element, 3s or 3, 0, 0s or 3, again 3, 3s or 2 will be 1, and 1s or 1 will be 0. And if you keep on checking and will always be 3 and 3, 3, 3 and 3, 3, 3 and 2, 1, 1 and 1, 1. So your and will always be greater than equal to 0 if we go from this side. And if you go from this side, as we made 1 and 2, 0, that's all that, I mean, that's how we designed the solution, right? So and will be 1 and 2, 0, and after that and will be 0. But 1 and 2, XOR will be 3, and 3 and 3, 0, 0 and 3, 3, 3 and 3, 0. So basically, in this way, you can satisfy the condition. So actually, you can solve this in O of 1, okay? Hello?
Understood.
I know, I know the problem was actually, see, the D problem, I even felt that the fourth problem was harder than the fifth one, okay? It is quite, you need to have quite observation for this. So this is the solution
What
you
if
can see. Yes, what?
what if we put all the values as 0?
The what?
If we put all the values 0?
See, no, you can't put it is written that AI should be greater than equal to 1.
Oh, yes.
Is it clear now?
Yes.
See, what I did now, I know you might have some confusion still. Uh, Try to implement the solution as I said. And after that, if you face any problem, you can ask in the group as well. And for now, I am showing my solution. See how I have implemented it. See what I did. This is the solution. Okay, one liner. You just need to check. You need to print 3 and minus 2 times. And for the last two elements, you can do 2 and 1. I observed that 1 and 2, if I do so, then it will becomes 3. Okay, after observing. Is it so? Is the fourth problem clear? Hello,
Hello?
hello. So is the fourth problem clear?
Yes, clear.
So let's move to the first problem. This is triple prime. So Chef has given you an even integer n. Find whether there exists three distinct integer a, b, and c such that a square plus b square plus c square is equal to n. So let's move to the board. So you have this problem. You need to have a square plus b square plus c square is equal to n, and these a, b, and c belongs to prime. So did any of you try this problem?
Yes.
So what was your approach on it?
Uh, since n was an even number and there are
Hmm.
three prime numbers and 2 is the only even prime number, 2 has to be
Yes.
included, because if both the three prime numbers were odd, then their sum of their squares would also be odd. So I had
Yes.
included 4 in it. So n minus 4 would be the sum of two prime numbers. Sorry, sum of the squares of two prime numbers.
Okay.
other than 2.
That's great. Yeah, it's a good observation. See, I mean, that's a great observation. You had to do the same thing. Now, the problem says that a square plus b square plus c square is equal to n. Okay. Now, we know that except 2, all the prime numbers are odd. So if sum of three odd numbers can never be even. So one of the numbers needs to be even, and there is only one even prime number, that is 2. So one of the number needs to be 2. Okay, suppose a is 2. So what happens is b square plus c square is equal to n minus 4. So you've reduced the problem from 3 variables to 2 variables because your a is always 2. Now for b square plus c square equals to n minus 4, you need to implement it. How would you implement it? Sonav, did you implement the solution?
Yes, I took different values, different prime values for b, and then I subtracted the square of it from n minus 4. Then I checked whether it
Yes.
was a square root or not. I mean, a perfect square or not.
Okay. So was it accepted?
No. Oh, I
Still
forgot
a
to check whether the cube root was sorry, the square root was a prime
square
number
root.
or not.
See, have you heard about sieve?
Yes, I
Have any
have
of you
heard
heard about
about it,
sieve?
but I have not seen how it works.
See, while solving for prime, I mean, whenever your solution involves prime numbers, it's a better way to actually generate the prime numbers at first and then keep checking. It's quite easier. So what we will do is b square plus c square equals to n, right? Now, is there any boundation on b and c? Tell me. I mean, is there any range? Although it's given that n lies between, I mean, n is less than or equal to 10 raised to 10, but is there any boundation on b and c? See, you can see that b has to be less than or equal to square root of n, right? In fact, it has to be less than square root of n because
Yes.
it can't be 0 because their sum needs to be n. So they can't, I mean, the individual square cannot exceed n, right? So it has to be less than square root of n. So b comma c both will be less than square root of n. So what I will do is that I'll generate all the prime numbers from 2, I mean not from 2, from 3. Why 3? Because 2 we have already taken, and see, the problem states that distinct, all these 3 numbers should be distinct, right? So if I have taken 2 as one of the number, then I'll have to take e and c from 3, because 3 is also a prime, from 3 till all the primes in square root of n. So what I will do is that, hello,
Yes, we can also take root over n minus 13.
and actually it's not n minus 13. Can you explain why?
Since we have already taken 2 over here, so b square plus c square
See, it wouldn't,
less than equals 2.
see in order notations, it wouldn't matter much. Okay, you can optimize that, but it's still order square root n operation, so it doesn't even matter. And there is okay, there is also one observation that see a square. Okay, let me take that. See a square plus b square plus c square equal to n, right? So although it has been, see, in the problem states that your n lies from 0 to 10 raised to 10. But you can observe one thing, that your n has to be, see, if I take even the smallest numbers, 2, 3, and 5, these are the first 3 prime numbers, then also n equals to 38, right? Is it clear?
Yes.
So see, since the number needs to be distinct, even if I take the 3 smallest numbers, n equals to 38. So for the values where n is less than 38, there is, answer is simply no. See, I have also written in my code that if n is less than 38, simply print no. Now for other cases, what we will do is that we have already found out a equals to 2. And for b and c, what we will do is we'll find out all the prime numbers from 3 square root of n, and in between we'll check if the sum of two numbers is equal to n minus 4, right? Because we have already taken 2, so we'll bring this 2 to here and n minus 4. So b square plus c square equals to n minus 4. For this, we'll look this. So I have implemented it using math, and you can implement in a lot of different ways. Basically, you need to have two numbers whose square is equal to n minus 4. So let me show you the code. So this is my code. See, I have taken input n, and I have checked if n is less than 38, then simply no.
Code is not visible.
Okay, is my code not visible? Wait. Um, I've taken input n, and if n is less than 38, simply print out no. And after that, if n is not less than 30, then we can have an answer, right? So I have reduced n by 4 because one of the number is 2. And for the rest of the numbers, I created sieve, okay? I generated prime numbers from 1 to square root of n. I have generated till 10 raised to 5, okay? Because n, your um, the n is lying between 1 and 10 raised to 10. So its square root will be 10 raised to 5. So I have generated till 10 raised to 5. And this is the code for generating sieve. If you know sieve, then you'll know it. And after that, what I have done is for every prime number, I have calculated its square and put it in a map. So my map has the square of every prime number between 1 and square root of n. And after that, I ran a for loop and I checked if the sum of two squares is equal to my n minus 4. And how I did that, I checked if the prime number and its and complement, basically n minus I square and I square, this will be equal to n, right? And also I should be distinct. For this, I have checked this, that I squared is not equal to n over 2, because in that case, simply I will have two same values, but I need three distinct values. And after that, simply print the answer. Hello, is it clear?
Yes.
See, this is the implementation. Don't focus that much on the implementation. Focus on the logic. I have explained the solution. You can try it on your own. And if you have any problem, just ask it in the group. We'll be happy to help you. So I think there's no more problems to discuss right now. If anybody having any doubts, so you can ask. So is everything clear? Please someone write yes or say something. Otherwise, I wouldn't know, right?
I had a doubt regarding
What?
the a power b mod c question.
See, it's we can't just discuss for you. Okay. If you have any doubts, personal doubts, you can ask in the group. See, because it's already 12:15, right? If we discuss that problem now, it would take a lot more time. You can
Okay.
ask that you can ask that problem in our group. Okay, we'll be happy to help. We can't extend the session too long, right? Because it's too late in the night. So, in the first five problem, is anybody having any doubt? Okay, then we'll end the meet. You can leave.